remember, don't try anything that you see at home.
We're what you call amateurs.
On this electrifying episode of Mythconception Busters, the guys test whether more expensive wire is the best wire. Will it be the pretty and expensive copper wire? Or the old, ugly, and recyclable aluminum cannons? Who are the Mythconception Busters?
Two guys walk into a hardware store and they say to the hardware guy, "What wire's the best?" What does he say?
I don't know. What does he say?
He says the most expensive wire's the best.
Why is it the best?
Well, we don't know. We don't know if it is or not, but we're out to test this myth and potentially to debug the fact that it's a misconception.
Hey.
Yeah.
Seems like a plan.
Let's go.
All right.
So the misconception we set out to test here is that the more expensive the wire is, the better it'll be at transmitting electricity. But we want to know why this is a misconception.
Okay. So usually the more expensive the wire is, the better it conducts electricity and transfers that electricity more efficiently. So
why is that? Like, is there more resistance?
I feel like that the more expensive wire has the least resistance, therefore it transfers it more efficiently.
Okay. So we're setting out on this project to test whether this misconception is true and that the more expensive the wire is, better it'll be at transmitting electricity, or if all wire basically transmits it's the same wire type at least.
Alright, so in this project we have 4 kinds of wires, 2 different types of copper wires and 2 different types of aluminum wires. It will be connected in a series with a battery of 1.5 volts to see which wire powers the battery the brightest. Therefore, we will find out if this misconception is true or false.
Alright, let's go.
Let's go. Electricity is a form of energy resulting from charged particles.
An ohm is defined as a resistance between 2 conductors. So, how do we calculate for this?
So, with the equation I is equal to voltage divided by resistance, I being the current or the electrical current, we can derive different formulas in order to help our project. The resistance is equal to the voltage divided by the current. We can also find the voltage of the system being the resistance times the current.
So the 2 materials we're using in our tests are copper and aluminum. Copper has a resistivity of 1.68 times 10 to the negative 8, while aluminum has a resistivity of 2.65 times 10 to the negative 8. Now, since we're also given the 1.5 volt system and the resistance of the wires, we can determine what the current of the system is theoretically. However, because there's both physical and chemical differences within each wire, the misconception that the most expensive wire is the best stands to reason.
Alright, we have scissors. Okay, so we have the base now. Okay, so these are the batteries, right?
Yeah.
Okay, that's good. What else do we need?
We have our recycled Coke cans. It's a full one.
Aluminum. wire. That's nice. So we have two copper wires here. Yeah, this is the more expensive one. And for the aluminum, we're gonna use recycled Coke cans, right?
Yep.
Alright.
Which we will cut with scissors.
Okay. I'll just use like a battery to straighten it out. Make sure it's straight.
Handy dandy tape.
Yep. Okay.
We're gonna see if the light bulbs are working.
Obviously,
Make
it's
sure they're not faulty.
make
Part on the bottom. And then
oh, well, lights up. It's pretty good. I didn't know it could do that. Okay, so obviously it works. It's just like engineering flaw right here.
so that's when we have to fix it.
That's a good point, Corey.
Thank you. Put it at the bottom.
Oh, that one works.
And it's working.
Okay, now let's try the aluminium.
Yes, we will switch over to the aluminum now.
Okay.
It's on the bottom.
Okay. So, obviously, we can conclude that like some metals they don't carry electricity that well.
So let's
Oh, let's do like a separate test for this wire.
yes, we will put this here. Put this on the bottom.
No. Oh,
And look at that.
it lights up.
It does light up, but it's not as bright as the thicker wire was.
Yeah. So, what? I wonder why, Corey.
Now, this could be for a few reasons. The first reason I can think of is that the side is probably anodized with some material to give the Coca-Cola logo.
Okay, so, like, the thinner wire we used here didn't power the bulb, like, compared to the other wire because of the diameter. It was greatly, it's greatly smaller than the other one. So less electricity can flow through it. That means the more resistance there is. And the most expensive here has a large diameter and probably the least resistance. That's why I was able to make the bulb shine brighter.
So basically what we can conclude about this is that the more expensive wire does turn out to conduct electricity better just because it's less resistance, it's probably purer than the cheaper copper is. It did not work.
Okay, so like, what do you think one flaw of our project was, Corey?
I feel like because our can is cut so long, after this length, the resistivity is too much to actually power the light.
Okay, that's a good point.
Just one more time. Let's watch this roaring grow. Brighter than any of the other ones. Very nice.
Okay, so one more time we'll show you that this one conducts electricity.
Yeah.
Cheaper copper, I think, might be an alloy to mix with other metals. As you can see, like it's lighting up, but compared to the other one, it's kind of like it's weak, honestly. So I guess this misconception turned out to be true.
I personally thought that the metal type wouldn't make any difference, but it turns out that it did.
Good point. Okay, I guess that's it.
Yep.
Congratulations, my fine sir.
And come over here for a sec. Look at that beautiful view.
We got our chance to work here on
Now
this
we're-
glorious campus.
Now, the sun is coming down and our job here is done.
Goodbye, Prospect.
This has been your daily bulletin.
It's
Thank you.
been a long day without you, my friend. And I'll tell you all about it when I see you again.